Yes, we are actually seeing the classification techniques so far. Can anyone mention what are the classification techniques we have seen so far?
Classification is logistic regressions, decision trees, and KNN, K-means, and you can also use.
K means
Sorry. K means clustering. It's not classifications, and we can SVM, sir. SVM classification also we can use, but
what
we
we have
can.
seen so far. I'm not asking what we have seen so far. We
Okay,
have seen logistic
logistic
regression.
decision trees, KNN.
Yes, we have seen these things so far as you in the state, and we have seen when to use what also. The another thing what we are going to see as you in the state is we are going to also see support vector machines. But let us see how these things are going to work. And along with decision tree, we are going to see something an ensemble classification technique also.
Random forest. Huh?
Yes. So we have these many classifiers actually present. Now we are in the position to understand when to use what we have already discussed during the study of these things itself. We have discussed when to use what, right? So what you understand from these charts A and these chart B, what is the difference between chart A and chart B here that is visualized with respect to the data distribution? What is the difference between these two, A and B?
Sir, in A graph we have
Overlapping
two
is more, sir.
categories. Sir, in two
Great.
categories were
Yes.
differentiated in.
Now, let me ask a question. Like Sandhya rightly pointed out, there is something called as overlapping. This is having overlapping, or this is having overlapping,
B, sir,
or
B have more
B is
overlap.
having overlapping. Very good. B is having overlapping. Let me take some different color. So this is having overlapping, and which is linearly separable.
A1, sir, A1 can be
Yes.
linearly.
Yes, so A1 is linearly separable. We have an algorithm which is directly related to linear regression, that is logistic regression. So where we want to draw some straight line or something, and using that straight line along with some sinusoidal wave, we will be classifying that there are two classes, and those classes can be separated with respect to those sinusoidal waves. So this is actually linearly separable. I can say this is going to be linearly separable. Now we need to map algorithm. There are only two things, but there is a thing to understand here. If it is overlapping, whether any outliers is there or not. If it is not overlapping, whether it is perfect or not. Like that, some questions will be there. So I can write fully. It is linearly separable. Now in today's class, we can come to a conclusion, which is actually best of these five. Actually, right? We'll have a conclusion like that. Now this is we say this is linearly separable, so that I can draw a line like this and say that points below this line are going to be black, and points above this lines are going to be some pink or some color, right? Then the question what comes to our mind is whether this is an outlier or an error point. So that is the question which will come to our, and what is about these points, and what is about these points, because they are wrongly classified. Whether they are wrongly classified, if they are wrongly classified, then I will consider those points as error points, because they are actually correct, but my model predicted it wrongly. It is actually with respect to whom this logistic regression person will be saying like this, and this SPM also will be saying like this. We will see SPM in the near future. Both of them will say that yes, I can separate with either a straight line, or he will say I will separate with a plane, that is probably an hyperplane, and say that one side I'll classify as class 1 and other side I'll classify as class 2. Now the question is, what about these points, whether they are considered as outliers or whether they are considered as classification errors? In what way you will classify that when you take this logistic regression or support vector machines? Whether you will be saying that as classification error, or whether you will be saying them as outliers.
Classifications error only, sir.
Very good, very good. Why classification errors? Can you say that in detail?
Sir, because we can see, we can also see that the points were not very large, sir. If the points have
Yes.
the distinct values from other values, means we can consider it as outliers. But there are similar values, right? The distance is very small, sir, in between two
Okay.
points.
But the thing to consider here is we need not use the word distance. Why? Because distance and all will be used by these people. So we don't want to use the word distance. Otherwise, the your point is correct that they are not actually separated mutually from their existing points. The thing is, we have classified them wrongly. If I try to fit this line in such a way that these points are also covered, then it is good. But my line is not that bending. So since it is not bending, we are actually saying that these are classification errors. Now coming to the, so we know that if the data distribution is linearly separable, I can use either logistic or SPM to do that. Now coming to these people, if the data is overlapping. Now what Yukendra says or Sandhya says will come into play, that whether these points will be considered as errors or outliers. The thing over here is, here there is an effect of outlier surely. Why? Because if I was saying that there are two classes present, there should be some sort of deviation between the 2 points, two different classes. But all the classes are completely overlapped and there is no means of directly separating it. There may be some other characteristics, but we need to separate. Now, what this KNN person will do is, say for example, I want to take some a particular point, say test point, say red. If I want this point to be classified, what KNN will do? KNN will consider who is nearer to me. So he is nearer to me. So if you say K is equal to 1, then I'm pink. If you say K is equal to 3, then I was black. If you say K is equal to 4 or so on, and I'll be changing my characteristic then and there. So what is the effect here is, here we consider that the points will be outliers, but there is algorithms that treat the outliers differently. K nearest neighbors will not consider any point as outlier, even though it is an outlier. Why? Because if I have a point, say x here, even though it is an outlier, if you increase some k value closer to this, this also will be taken into account. This will not be dropped. So KNN will not neglect the outliers. Even though it is an outlier, it will not neglect. But then how to get rid of that? Increase the K value. Fix a very good K value so that you will be getting rid of those outlier classifications. And if I take decision trees, they are somewhat smart. What they will do? They will say, on what basis I have to do the classification. So I have entropy and Gini metric that will clearly recommend me what are the impurities present in the data. So if there is missing data or outliers, this decision tree is able to classify it accurately. But the thing over here is, it will not say which point is an outlier. So there is a possibility that some good point, say the points like these things, which need to be considered as classification errors, may be considered as outliers by using decision trees. So that's what the problem is. Why? Because if you choose any wrong feature as the root, then if you do the classification with that as a root, surely some bias may happen. Right? Now I ask you a simple question. If I have a decision tree like this and I do classifications like this, and say for example here I'm going to the depth of 3. Now the depth of the tree, say assume it is 0, 1, 2. So totally 3 levels are there. So depth of the tree is now 3. If I increase the depth of the tree, then what will be the notation? Whether my accuracy will increase or accuracy will decrease. I mean the training accuracy first. If I increase the depth, what will happen? If I make
Sometimes
it,
it will decrease, sir.
Accuracy will increase, but the time complexity
Decrease.
will increase also.
you
I
say,
mean, time.
see, I mean the training accuracy in which the data is being trained. Training accuracy will increase or decrease. If you go as deep as possible, it will memorize everything. Am I right or
Increase.
wrong?
It's underfitting, right?
If
Training
you
data.
go if you go as deep as possible, then what will happen? It will learn everything and do all the classification, and training accuracy will increase. And if training accuracy increases, what happens? My variance will
Testing
increase. I'll be having something called as overfitting. Because you
or
don't go as deep as possible. If you go as deep as possible, it means that you are memorizing everything. So when I give you any new sample, then it will have high variance. So you will be having poor testing accuracy. On the whole, testing accuracy will be drastically reduced. So only we use something called as Occam's razor and have a shortest hypothesis and so on. So those are the problems with respect to decision trees. To overcome the problem of decision trees, the thing is I cannot go as deep as possible also to learn everything. So what I can do is, I can make different types of routes for different levels. I need not take the same route. I can take different route with respect to different data. So I need, instead of constructing a very large tree, I can construct 3 or 4 small trees. So I will have several small trees, and for each of the tree I'll do classification, and all the trees will be small hypothesis, and I'll combine the result of those by using some majority voting scheme, and I'll take the classification result, and that I call it as ensemble classifier. That is what we are going to see in today's class, right? Let us see it in detail, right? Shall I erase these things?
Sir.
Yes.
Yes, sir. Okay, sir.
Yes. So I'll erase this.
So then, what is difference between random forest and assemble classifier in decision trees, sir?
Are assemble technique and
A
random forest.
random forest is one of the examples for ensemble classifier. Ensemble is nothing but instead of taking a single model and applying a learning data, it ensemble will take multiple models and combine the results of those models. Decision trees is, we are going to see one of the example of ensemble as random forest. Random forest and decision trees are closely related. Why? Because random forest is equivalent to multiple decision trees. That is what we are going to see now, right? So we'll
Nothing
see
but
that now. Yes,
bootstrap aggregator and కూడా అంటారు కదా.
yes. So let us first see that random forest.
Sir, all the boosting techniques were used random forest concept only, sir, maximum, right?
Not only random forest. I do one of the thing in my MTech. If you see that handwritten documents, it actually does both nearest neighbors as well as another technique, and it will combine the effect and give the result. If you see in deep learning also, some of your RB also done that. It will be taking two different algorithms, say GoogleNet and ResNet, and what GoogleNet says also it will be recognized. ResNet says also will be recognized, and ResNet 50, ResNet 100 both will be taken, and it will be giving the result. Out of those three, which is giving the maximum result, I'll take. So that is also an ensemble. It is not that only decision trees need to be replicated. Any different algorithm you want, you just apply to the data. But only what is the deficiency is time. Instead of constructing a single model, you are constructing an odd number model. So surely your time will increase. If you, but accuracy will have some found pronunciation. So you can use that ensemble technique, right? Let us now see how that ensemble classifier will work. So generally, as Vikender pointed out a right word, it is going to be something called as bootstrap aggregator. So let us see what is that bootstrap aggregator. So assume that I'm having some data. Let me take that pen. I'm having some data set. So this database is there, and I need to train a model with respect to this particular database. This database will have several rows and several features. That is, features corresponds to columns. And what I will do is, I will first use any one model to be trained with respect to this particular data set, and I call that to be model 1. You don't consider this as a decision tree. Let us say any model 1 trained using a particular learning algorithm. I'm training it. So how I'm going to train is, I'm not going to train it with the data entirely. I'm going to take sample 1. I'm going to take any random sample. So say for example, randomly these two samples are taken, and I say S1, and I train model 1 with respect to S1. So this is my first model. Next, what I do, I take another set of sample, and I develop another model M2, which is going to recognize the same database for the particular output with respect to a new sample, say S2. The thing to understand here is, none of the data in S1 is going to be present in S2. That is the most important thing. S1 and S2 are mutually exclusive, means that none of the data in S1 is going to be repeated in S2. That is the main criterion over here. And none of the features is going to be different. That is, I'll have several rows and columns. Say for example, these are the rows, feature A, feature B, feature C is the column, and I have several rows. So in this particular ensemble technique, only the rows I'm going to take. Only the first 2 rows for model 2, remaining 3 rows for model 1, and so on. But all the features are common actually. I'm not going to do anything with respect to features, that is the column names. Only the rows I'm going to take it different. right? Next, what I will do, I'll take another model, say model 3, and I can go on. The number of models is going to be an hyperparameter for me, so that as that is up to the developer. So I take model 3, and so on. I can go with several models. Let me take an odd number model because I'm going to do some majority voting here.
Voting classifier.
So I'll have something like S1, S2, S3, S4, and S5. So those are actually samples which are not having any repetition. The content in S1 is different from what is present in S5 and vice versa. So this is the thing. Now, Yendra used one word, right? That is bootstrap, right? I'll explain that is what is bootstrap. Bootstrap is nothing but it is the entire data set, meaning the boot is going to be strapped into different models. So I call this particular term where the entire data set is having been sampled into different models. I call it as bootstrap. So I'll name it here. So this parses from one to many, I call it as bootstrap. The thing to understand here is the sampling. So I also call the sampling as I'll take this instead. Yes, that is row sampling with replacement. So if I say without replacement, then what will happen is then the repetition may happen. If the any rows present in S1 is also coming in S2, then immediately I should do a replacement because both should not be same. If I take another random sample from the database to form S3, and if I found that some of the data of S1 and S2 are repeated in S3, then immediately I should do replacement. So I call this as bootstrap with row sampling with replacement. This is actually the first step, right? Then what I will do, then I can get the result from each of those models. So each model will be giving me some classification result. This may be giving me classified as 1. This may say it is classified as 0. This may say 1. This may say 1. And this may again say 0. Then what I will do, I'll do some random thing over here. I'll do some classification point. I'll take the majority voting because I'm having 3 different algorithms, each giving me some good result, and I'll be taking the best of those by using a majority sampling. Usually, an odd number term is given to break an even time where both the classes are having the same classification results. So I call this as what majority voting.
That is nothing but voting classifier.
Yes, voting classifier.
This is for regression model.
This is not for regression model. For regression model, we will not use
Sorry, this is
majority classifier.
classification model. For regression, we use the mean of the totes, mean
Yes,
of the outputs,
yes. Mean
not
or
the
median can be used. Mean,
mean or
median, or
median.
mode. So this is actually the majority voting classifier. So this is actually the basic model for ensemble classifier, and this particular thing, which is actually getting the classification from individual models and compiling it everything and then bringing that to the majority voting classifier. I call this as aggregate.
Aggregator.
So this together is actually called as bootstrap aggregator by the name, right? So ensemble classifier is also known as bootstrap aggregator. Why? Because a single data set will be there. Instead of assigning the entire data set as converting into training and testing and giving to one model and get the result, I can give it to multiple models and have a majority voting criterion. But there is a problem associated with this. What is the problem is time. Why? Because time as well as resource. If I want to run a single model, then for running that model alone, I can allocate the resources. But if I want to run 5 different models for the same data set, just for the accuracy point of view, then I need to use some extra time as otherwise an extra resource. But there is actually recently many algorithms came over for running the ensemble classifiers, and that algorithm says that utilization of parallel algorithms. So what the parallel algorithms will do, they will be taking these things. We know that execution of M1 is nowhere related to execution of M2, M3. Similarly, execution of M2 is nowhere related to M3, M4, M5 or M1. So they are actually mutually independent. They can be running in parallel. If they are run in parallel, then the time for execution of M1, M2, M3, M4, M5 are same. Why? Because they are running in parallel. But what will happen? I need to use some extra resource. I need to use some higher end hard disk or some RAM or so on. Right? I need to use those higher end configurations to run these ensemble algorithms. But as a result, we say that ensemble algorithms are actually good in giving accuracy level. But there are some data set, even though you use ensemble classifier, there is a possibility of getting some wrong results. Why? Because if the data set is having more number of outliers, then some models will be getting the samples pertaining to that outliers alone, and they may mislead our data. So those things also are possible. So you should not think that for every algorithm you can use ensemble. For every data set, instead of going for a single model, why not to go for 3 to 5 models so that we can get better result? That is actually a wrong kind of thing, because if it is a single model itself, it is getting a good accuracy. We cannot go for multiple models. So this is the basic of ensemble classifier, right? Am I making it better?
Yes, sir.
Yes. So the same thing, let us see how the random forest will do. The thing what I'm going to say separately is this row sampling with replacement. In random forest, it is slightly different, right? So this row sampling says that the only the rows are going to be changed, and there is nothing to touch with the column names or features. These are not at all touched in this particular introductory portion of ensemble classifier. Now let us see how random forest will work, right? Yes. Shall I erase this? You can take screenshot.
Yes, sir.
Yes. We'll take random forest classifier. Now how random forest will behave with respect to this ensembles. Now in random forest also I'll be having the entire data, and here what will happen is I'll have something called as the feature set in my column. My column feature set will be there. C1, say C1, C2, dot up to Cn. I may have up to some Cn. I'll have several columns, and each of those column I call it in the name of features. I have several features, and I may have several rows. So several rows will be there. Now what I will do is I will not randomly pick the rows alone. I'll be doing two things. One is taking with respect to the features, right? Now we will say how the random forest classifier is going to be related. Random forest classifier is actually closely related to decision trees. D trees. I call it as D trees, the function and used in scalar. So what the D trees will do? D trees are normally decision trees that will take the data and try to find the better split for each particular feature. It will do some operations including information gain, Gini, entropy for identifying the best attribute, so that my classification under my decision tree will be having best fit. So that is with respect to D trees. Random forest is actually you make the use of the name forest. So combination of many trees. So random forest is a combination of multiple decision trees. It is going to construct many decision trees. So this is going to be decision tree one. So I call it as D one. So DT one means that decision tree one, and this is going to be decision tree two. I can construct any number of decision tree, and for each decision tree, I can specify the depth also. So this may be decision tree 3 and so on. I can have many decision trees, and for each of the decision trees, I can specify the depth. Coming over here on how to assign the sample for each of the decision tree model is, here not only with respect to the rows I'm going to make a sample, I'm going to make sampling with respect to the features also, the columns also. So based on both rows and columns, I'm going to develop something as a feature and give it to decision tree 1, and that becomes sample 1. Next, I give some features to sample 2, and next I give some features to sample 3. The thing to consider over here is you will not have anything directly related. Say for example, I take a data set. This data set will have some features. Let me draw a sample data. This will be considered as A, B, C, D, and E. Now I have 5 features and I have several data available directly. And each of those data, what I will actually do is, in a normal ensemble classification, we say that features is optional to get sampled. But in random forest, since it is decision tree based, it should not have the same features for all the decision trees. Why? Because if you give the same features for all the decision trees, then all the decision trees may choose the same attribute as the best attribute. So I doesn't want that to happen. I'll repeat one more time. If you use all the 5 attributes, 5 feature A, B, C, D, E, and E, then all the 3 decision trees may consider C as the root and say that all the classification should be done based on C only. So that may happen. In order to avoid that, it will not give all the 5 features, or all the models have to have the same features. So what it will do, it will first select this particular sample and give it to decision tree 1, that is having A, B with this many number of rows. Next, it may consider B, C, D, and it will give to D2, DT2. Next, it may consider A, B, and CE together, A, B, and DE together. Together, it may give it to these two together. It may give it to decision tree 3. Like that, it will actually have several combinations of features and give it to several decision trees. You can also specify how many decision trees you want and how much depth each decision tree should have, and what is the random state. Everything you can give it to the random forest classifier. So if you do such things, it is not only row sampling with replacement. So it is actually something different and named as feature sampling and row sampling. Now I don't use the word with replacement. I don't use the word with replacement. Why I don't use the word with replacement is, if I use A, C, D, and E, if I use the word replacement, then what will happen is, if this particular column, say, if you take A and B, then this particular column is already used. Next time, if I use A, C, D, and E, then if I don't use this particular row, then this particular cell, this particular cell, this particular cell, this particular cell, everything remains unused. Because of just that this alone is being used, this and all will remain unused. So I don't do any replacement here. Why? Because the features are replaced, but the rows will be randomly selected. And if any row present in dt1 is also present in dt3, it doesn't mean that it should be replaced. Instead, what I will do, I'll make a confirmation that dt1 and dt3 are not having the same column names or same features. That is what I consider here. So this is with respect to feature sampling and row sampling. Am I making it clear? What is the difference between the normal ensemble classifier and how it comes to random forest?
Yes, sir.
Yes. Yes, for everyone. Am I making it clear how it is actually differing? Yes, I'm asking to everyone. Yes. If I'm not making clear, shall I explain one more time? I'll have some data. I'll be having several rows and I'll be having several features. The thing is, I should not give the entire data set through the same model and get trained. Instead, what I will do, I will take the data, I will take some set of features for some set of rows and give it to DT1. Of those features, which is the best attribute, it will select and keep it in the root. It will do some classifications and it will build a decision tree. Next, it will take another decision tree, they say D2, that will take some other different features. The rows can be replicated, not entirely, but because the features are not common between DT1 and DT2. So I'll take some other different features. I'll be creating an entirely different decision tree. Similarly, I'll get a DT3 as another entirely different tree, right? So in this way, I have to do the modeling, right? I'm making the decision trees clear. I need some chorus answer.
Yes, sir.
Yes.
Yes,
Chorus
sir.
answer is single answer. Okay. Yes. Now, as I said, the aggregation step is actually common as we say, as we see it in the normal ensemble thing. We take some aggregator when decision tree says something classified as 1 and this say classified as 0 and this say classified as 1. I'll be doing the aggregation that is common to what we saw in the ensemble technique itself. The aggregation step will actually combine these things and will give us some right point where majority voting will play a role. So we'll do some majority voting and we'll be getting the right result. The thing to understand here that the main point is feature sampling. There's not only row sampling, I'll do something called as feature sampling also. That will make my model different. I make each model in my ensemble technique to be different, right? Tanuj, am I making it now clear? What is actually the difference between decision trees and random forest?
Yes, sir.
Yes. So now, based on my experimentation, I have just now done it. I'll show that. If I said one word, right, it is not good to use ensemble every time you want. I just took for explanation. Shall I erase this first before I'm asking a picture? Shall I erase? I'll go to the next screen and erase it. Shall I erase and go to the next screen? These things, feature sampling, row sampling, these are all keep in mind so that when I ask some MCQs or quizzes, you can make use of these things and understand. So you take screenshot of these so that will help you, right? Shall I erase this?
Yes,
I'm very
sir.
yes. So I'll go to this. This is actually, hope you remember, we had a decision tree classifier what we used and compare it with the naive base. So I'll go to the top so that you'll remember what program it is. We used ODI match classification by using decision trees. We took the ODI data. In the recent lab, we have done this. And we have done several pre-processing with respect to host, who is going to be a winner, match result, everything. Several pre-processings we have did. And we have applied a decision trees and got an accuracy of 60, right? 0.65, I hope. 0.65 is accuracy what we obtained here. Why I'm now going to say this to you is I have applied a random forest here where it is actually not required because that much increase we are not finding here. When I applied a naive Bayes, we have found that only 0.51 is there. And when I applied a random forest, the accuracy is slightly improved, not very much. It is slightly improved to 0.66. And that to see, I have kept the depth as 13. Only in the depth of 13, it is actually increasing. If I increase the depth, it is again decreasing. It may be the global local maxima, but we have to fit by using some trial and error test by running it to a for loop and see what is the best depth value, right? It may be local maxima, and but if I increase to 14, it is actually decreasing. So this is an example for saying that always ensemble is not good. You can use ensemble when it is actually required, and when you think that yes, there are more DAX for this particular data set when the dialect is more. But the meaning for dialect in the sense, there are many ways to identify the prediction for this particular data set. There is not only one approach, several approaches are actually involved in this particular data set. That I mean dialect. So when many dialects are there in this particular data set, then I can use ensemble. Doing the same thing again and again will waste resource also, waste the time also. So ensemble is actually useful only when you think that you have enough data and enough variations in the data, then that will provide you some sound accuracy. If the accuracy is only slightly improved, they say 0.1 percentage between say decision trees as well as random forest, then this random forest classifier is not giving me that much better result. Why? Because this is just a training accuracy, not a training and test accuracy. This is not a wherein my decision trees may have some better accuracy than random forest. Why? Because a single model is actually gaining a better result than the multiple model term. So before using ensemble, we need to keep in mind which is actually the better term, right? Now let me explain you some other MCQ facts or some other or ensemble classifiers. The main advantage what I can say to you is random forest has less prone to higher variation. Can anyone say what is the definition for overfitting, whether with respect to bias and variance? Low bias or high bias, low variance or high variance for overfitting? No one
High
remember?
var- High variance, low bias.
Yes, great. High variance and low bias. Random forest will not allow high variance because it is using something called as a majority voting scheme. Surely the variance will not be higher. So what we can accrue? So overfitting is rarely visualized, or rarely in the sense that rarely word is also higher, which barely visualized in random forest. Where in other schemes, in few decision trees, one of the major drawback itself is overfitting. Because if we will be going as deep as possible to understand the data. But if it is going the more than a particular depth, we'll see that okay, it is overfitted. But we need to understand something only when we go to that particular depth. If the depth is reached, immediately overfitting will occur. So those kind of problems are actually available in decision trees, but random forest or ensemble classifiers will not that make that to happen. That is, it will not make a higher variance, right? Then coming to bias, bias will occur when there is actually a thing. For example, in linear regression, what we will say, if I bend the line, then it can actually fit more. But I will not make the line to bend. Why? Because my line is very stringent and it will not bend or it will not cover all the points. So we say that if it is not bending, so the bias is high, so it is not bending because it want to follow that equation y is equal to mx plus. So random forest will not have increase that also. And another most important thing is the concept of outliers. Even though you say there are several outliers in the data, I'm having several models, multiple models trained using random sample of data. Say the sampling include both row sampling as well as column sampling or feature sampling. Since I use multiple models, model training using random sample of data, the effect of outliers is rarely visualized because at least I'll have some quantity of the models which is not affected by that particular outliers. Usually, this is actually applicable for decision trees itself. Why? Because decision tree by default has something to detect an impurity. So when I group several decision tree models, surely I'll get that advantage in random forest. So these are the most important thing with respect to the advantage point of view. Disadvantage, as I already said, one is time and second is resource. So if I use ensemble classifier, then multiple models need to be trained. So the model development time will cost, and as well as if you want to run them in parallel to make the time reduced, then you'll need to use more resources. The third thing is deviation towards ensemble modeling over direct learning models. So direct learning models will be will be taking the entire data set to them. So some 70 percentage or 60 percentage, they will be getting trained and they'll be giving some good testing results. So if you directly apply any model without giving to the single learning model, if you give it to ensemble model, you will not understand the requirement of ensemble itself. You'll be thinking that okay, if I give that to ensemble, it is performing better. No, some models are available that will be performing better in single learning model and performing worse in ensemble models. So that also is available. You need to keep that also in mind. So we need to understand what is the deviation that is visualized with respect to ensemble model and direct learning model. If the deviation is more, if it is higher, that too ensemble model is giving you some higher result, then you can switch to ensemble. Otherwise, you should not switch to ensemble models, right? Now, I am making it clear the theoretical point of view of ensemble model and random forest. I am making it clear.